Today we're covering fine-tuning execution and evaluation, the point in the AWS Generative AI Developer Professional exam where AWS separates people who know the vocabulary from people who can actually ship reliable Gen AI systems. This topic is not flashy. It's about discipline, repeatability, and engineering judgment. Let's lock it into memory with a story you won't forget. The memory story. The train announcer disaster. Imagine a national railway system. Every day, millions of passengers hear automated announcements about delays, platform changes, safety notices. At first, the company uses prompting. They tell the AI, be polite, follow railway rules, always include safety language. But the results are a mess. Some announcements are too long, some are too casual, some forget mandatory phrases, some sound completely different from others. Nothing is wrong, but nothing is reliable. This is not a reasoning problem. This is a repetition problem, so the company stops explaining the job every day. They train the announcer. That is fine-tuning. Part 1. What fine-tuning really is. Fine-tuning means adjusting a model so it behaves consistently for one specific task. It does not make the model smarter. It does not give it new knowledge. It does not replace document retrieval. What it does is lock in behavior. The same tone, the same structure, the same style, the same phrasing, every time, at scale. What fine-tuning is not exam traps. Fine-tuning does not fix hallucinations, enforce safety, improve deep reasoning, replace RAG. If the problem is about facts, documents, or accuracy, tuning is the wrong tool. AWS is very strict about this distinction. Part 2, the fine-tuning execution pipeline. This is the workflow AWS expects you to understand end-to-end. First, you define the task. Then you prepare training data. Then you tune the model. Then you validate outputs, then you evaluate results, then you deploy, then you monitor and iterate. Fine-tuning is a process, not a button. Part 3. Step 1. Define the task. Fine-tuning only works when the task is repetitive, narrow, predictable, low in reasoning. Train announcements are perfect. Same structure, same safety wording, same patterns, millions of repetitions. That's exactly what tuning is for. Part 4. Step 2. Training data. The most important part. The model becomes what the data teaches it. Each example looks like an input message paired with the exact output you want. High quality matters more than quantity. Your data must be clean, consistent, correct, representative. If the data is messy, the tuned model will be messy, permanently. AWS loves this rule. Tuning quality depends more on data quality than on model choice. Part 5. What training data should look like. Good data has one style, one format, no contradictions, no unsafe content. Bad data includes mixed tones, conflicting outputs, scraped garbage, hallucinated examples. Once you tune on bad data, you bake in the mistakes. Part 6. Step 3. What tuning means in AWS. In AWS, tuning usually means parameter-efficient fine-tuning instruction. Tuning adapters, not retraining a model from scratch. This is cheaper, faster, safer. The exam expects you to prefer parameter-efficient tuning every time. Part 7. Step 4. Evaluation. Where engineers are made. Tuning without evaluation is guessing. AWS expects you to evaluate business outcomes, not academic metrics. You check. Are outputs consistent? Is the format always correct? Is the tone locked in? Did latency improve? Did token usage drop? Did cost decrease? If those answers are yes, tuning worked. The unforgettable evaluation moment. Before tuning, the railway reviews 1,000 announcements. They find 12 different styles, missing phrases, long prompts. After tuning, one consistent voice, mandatory phrases, always present, short prompts, lower costs. That's success. Part 8. What metrics matter on the exam? AWS does not expect blue scores or research metrics. They expect engineering metrics: format accuracy, error rate, consistency, token reduction, cost savings, latency improvement. If the exam asks how to evaluate tuning, these are the answers. Part 9. When fine-tuning helps. Fine-tuning is correct when output structure must never change, volume is high, prompts are repetitive, cost must drop, reasoning is shallow. Perfect for notifications, summaries, normalization, classification, explanations. Part 10. When fine-tuning hurts. Exam traps. Do not tune when knowledge changes frequently, answers depend on documents, deep reasoning is required, safety is critical, task variety is high. In those cases, use prompting, RAG, or guardrails. Part 11. Locking the tools in your head. If the problem is inconsistent style, fine-tune. If the problem is wrong facts, use RAG. If the problem is unsafe output, use guardrails. If the task is one-off, prompt. If the task is repetitive at scale, fine-tune. If the task needs thinking, choose a better model. Final memory lock. Say this once before the exam. Fine-tuning trains behavior, not knowledge. If you remember that sentence, Day 9 questions stop being confusing and start being obvious. Fast self-test. A system produces factually correct but stylistically inconsistent outputs at massive scale. The fix is simple. Fine-tune the model. That's fine-tuning execution and evaluation. Not hype, not magic, just disciplined Gen AI engineering.